Hi students, welcome back. In the last class we discussed about series and parallel combination of resistors. Today we are going to discuss about power in an electric circuit. Okay? Power. Okay. For this we want to consider a conductor AB. To this conductor AB, we provide a charge Q. Will this charge move through this conductor? No. To move this charge through this conductor, what we want to do? We want to do certain amount of work. Okay. That work is done. That work is done by the battery which is connected across the terminals A and B. Here the battery will do certain amount of work. We know that the work done W equal to Q into V. Okay, if Q charge moves in a potential V, then work done W is equal to Q into V. Okay. Now, what about power? Power P is equal to work divided by time. The rate of doing work or work divided by time is known as power. Now, we want to substitute the value of work. Work W is equal to Q into V, that is QV divided by T. What is Q by T? This is also studied. Q by T is equal to I. Therefore, we can write it as I into V. Then power P is equal to I into V. Okay, the first equation for the power is power P is equal to I into V. Okay, now we know that what is voltage V? According to Ohm's law, we can say that potential difference V is equal to I into R. Potential difference across the ends of the conductor is equal to I into R. Okay. We can substitute the value of voltage in this equation. So that's equal to I into, what about V? V is equal to I into R. Then I into I, it's equal to I square. Therefore, I square into R. Then what about the power? The second equation for the power is I square R. So, okay, the second equation for the power is equal to I square into R. Okay, on rearranging the Ohm's law, we can write I is equal to V by R. Okay, I equal to V divided by R. On substituting I is equal to V by R in the equation, power P is equal to V into I. It's equal to V into, what about I? I is equal to V by R. Then V divided by R. V into V is equal to V square, then V square divided by R. Therefore, the power P is equal to V square divided by R. That is the third equation. Power P is equal to V square divided by R. Okay. Now, we got three equations for the power. Power P is equal to V into I. Power P is equal to I squared R. Power P is equal to V square divided by R. Okay. These equations are coming from power P is equal to work divided by time. Okay. Therefore, power, we can again write the power P is equal to work divided by time. Okay. These are the equations for the power. Okay. We want to write the equation P is equal to I into V. Okay. Now, what's the unit of power? Unit of power is watt. Okay. Unit of power is unit of power. Unit of power is watt. Okay. This is the unit of power. What's the unit of power? Unit of power is watt. That's equal to unit of current is ampere. Into, what about unit of voltage? Unit of voltage is volt. Okay, then watt is equal to ampere into volt. Okay, to define watt, We want to put 1 here. This is also 1. Here also 1. Now we can define 1 watt. Okay. 1 watt is the power of the circuit. When 1 ampere current flows through a conductor having potential difference of 1 volt. 1 watt is defined as 1 volt. Potential difference is maintained across the ends of the conductor. Okay, the potential difference across the ends of this conductor is 1 volt. When 1 ampere current flows through it. What about the current flows through this conductor? It's equal to 1 ampere. Okay. This is the definition of 1 volt. Okay. Now, what's the practical unit? Unit of power is watt. Then what about the practical unit of power? The practical unit of power is kilowatt. Okay, kilowatt is the kilowatt. Kilowatt is the practical unit. Okay, practical unit is kilowatt. Okay, that's all about power. Then how can we define power? Power is the rate of doing work. Okay, power P is equal to W by T. From this equation, we can derive power is equal to V into I. Then substituting the Ohm's law, we get the equation as power is equal to I squared R. Again on rearranging the Ohm's law and substituting its value, then power is equal to V square divided by R. Then what's the unit of power? Unit of power is watt. Then 1 watt is equal to 1 ampere into 1 volt. Now we can define 1 watt as 1 ampere. When 1 ampere current flows through a conductor, when 1 volt potential difference maintained across the ends of the conductor. Okay. Now we want to find out what about energy. Okay, what about the electrical energy or heat energy produced in a conductor? Okay, we already studied that power is equal to work divided by time. Okay, on rearranging this equation, what about work? Work is equal to power into time. Okay, here work divided by time. Okay, then work is equal to power into time. Okay, what is work then? According to work energy theorem, what is work energy theorem? Work is converted into energy. Work energy theorem. Work is converted into energy. Okay, work energy theorem states that work is equal to energy. Work and energies are same. Okay, here the energy which is stored in the form of heat. Okay, then work is equal to power into time. Okay, we already studied the equation for the power. Power P is equal to V into I. Then V into I into T is the work done. Therefore, what about the energy? Energy is equal to VIT. And this energy is stored as heat energy. Then it is written as H. Therefore, what about the first equation for the heat energy? Heat energy developed in a conductor, H is equal to V into I into T. Okay, when current flows through a conductor in a potential difference of V volt, then heating effect is produced here and that heating effect is written as H is equal to V into I into T. Okay, again, work done W is equal to P into T. What about the second equation for the power? Second equation for the power is equal to I squared R. Therefore, I square R into T. Okay, then work is equal to I squared RT. This is the second equation and this work is stored as energy and that energy is known as heat energy H. Therefore, what about the second equation? Second equation for the heat energy is equal to I square R into T. Okay, now again we can write work is equal to power into time. What about the third equation for the power? Third equation is equal to V square divided by R. Okay, therefore V squared by R into T. Okay, this work is equal to energy and that energy is stored as heat energy. Therefore, the third equation for the heat energy is equal to V square divided by R into T. Okay. Now we have three equations for the heat energy. Heat energy H is equal to VIT, H is equal to I squared RT, and again H is equal to V square divided by R into T. When current flows through a conductor, around the conductor, heating effect is there. Heat it's a form of energy. Therefore, that energy, heat energy is equal to VIT or I squared RT or V square divided by R into T. Okay. The heating effect of current is studied by a scientist known as Joule, James Prescott Joule. The full name of Joule is James Prescott Joule. According to James Prescott Joule or according to Joule, heating effect H is equal to I square R into T. And he stated law. That law is known as Joule's law. According to Joule's law, heating effect produced in a conductor which is directly proportional to square of the current. Okay, that's the first term. Okay, heating effect is directly proportional to square of the current. And again, heating effect is directly proportional to the second term, that is the resistance of the conductor. And again, heating effect is directly proportional to time of flow of current through the conductor. Okay, these are the three factors that affecting the heating effect. What about that? Heating effect is directly proportional to square of the current. Again, directly proportional to resistance of the conductor. And again, directly proportional to time of flow of current through the conductor. Okay, and this law is known as Joule's law. Okay, then how can we state Joule's law? Joule's law states that heating effect produced in a conductor is directly proportional to square of the current, resistance of the conductor, and time of flow of current through the conductor. Okay, unit of heat energy is equal to unit of heat energy. Its unit is Joule. Okay, we already studied that. What about power? And what about the unit of power? Unit of power is watt. And what about the practical unit of power? Practical unit of power is kilowatt. Then we studied about what about energy. Equations for, we derived the equation for energy. Then what about the unit of energy? Unit of energy is Joule. Okay, now we want to study what about the practical unit of energy. Practical unit of heat energy is kilowatt hour. We already studied that work is equal to power into time. Okay, work is equal to power into time. Okay, work is known as energy or heat energy. Okay, heat energy, heat energy. Work is a form of energy. That energy is in the form of heat, so we can call it as heat energy. Heat energy is equal to, what about the unit of power? Unit of power is kilowatt. Kilowatt. Okay, what about the unit of time? Time here it is taken as hour. Okay, kilowatt hour. Therefore, what about the unit of energy, heat energy? Practical unit of heat energy is kilowatt hour. Okay, and it is denoted as kWh, kilowatt hour. Okay, so unit of heat energy is kilowatt hour. Now we want to convert kilowatt hour into joule. Okay, kilo means 10 raised to 3 or 1000. Kilo means 1000. 1000 into hour means 1 hour is equal to 60 minutes. Okay, 1 minute is equal to 60 seconds. Then 1 hour is equal to 60 minutes. Okay, then 60 into, instead of minutes, we can write it as 60 seconds. Okay, therefore 1 hour is equal to 60 into 60 seconds. Now we can put that value here, 60 into 60. Okay, that's equal to, 6 into 6 is equal to 36. What about the remaining zeros? 1, 2, 3, 4, 5. Okay, into 10 raised to 5. 36 into 10 raised to 5. That much Joule. Okay, or we can write it as 3.6 into 10 raised to 6 Joule. Okay, 1 kilowatt hour is equal to 3.6 into 10 raised to 6 Joule, or 36 into 10 raised to 5 Joule. Okay, that's all about today's portion. I think this topic is clear for you. If you like this video, please subscribe and enable the bell button. Thank you.